Good morning. Good morning, and welcome to the Ridiculously Early J Morning Show. My name is Michael, and I'm your host, and we're starting a little early today. We're just working through the process of, I promised the folks at J Software that I would go through and migrate their bugs over to, migrate their feature requests over to GitHub. I'm a little tired. Hello. Yeah, I'm just continuing with the bug triage here. So, let me get my screen set up. Default. Shift key to access. Okay. Okay. Somebody has opened a new issue. Let's see, something about this should subtract 3. Looks like a bug in 902. It works as expected in 903 beta. Okay, interesting. Okay, so this is a bug report. What we really need to have here is some kind of labeling system where we can mark things as being enhancements or bugs. And they have that, but I don't have the ability to set this. So they'll have to organize that themselves unless they want to give me access to that. We'll see. Okay, so anyway, where we left off was we went down this list and we got to about extend, yeah, if these are numbered, so this is extend fit conjunction. Extend fit conjunction. I skipped fast function definition because that's already implemented. And then I posted this one, and that one is also implemented. And so there's a closed issue here. So that's this one. So I talked about that already. So now we are on to, excuse me, semi-duals. All right, so this is under and under with a different rank. So they're talking about so this is from Henry again. I think this is the proposal. This says it is equivalent, but I think that they're saying that they want it to be equivalent. As part of this change, this is the gerund. So what do you call this? I don't know what you call this thing. It creates a gerund. I don't know what the actual name of the symbol is. Maybe it's just called gerund. This is ridiculous. Ridiculously small screen. Tie. Okay, so tie. Create a gerund. When you have a it's a conjunction that allows you to take a verb and kind of like turn it into this atomic form, or gerund form or whatever, and then it allows you to put nouns together, and so it's a box building system. I'm not sure if they're saying that this is already the case, if this is like this. Under dual. So the question is, what do you do if it's you and or you under n? So U and V indicate their verbs. So this is talking about n, where n is really a gerund here. So in the documentation it shows up as n here. So right now it looks like these don't take the gerund form. They don't take a gerund argument. Oh, well, hang on. Semi-duals, this operation encapsulated is by U under V is used often and is important as a notation to aid thought. When the operation is dyadic, sometimes the sequence of transforming, operating, transforming back should be applied to just one argument, with the other argument being passed unchanged into U. This can be represented by a gerund form where the empty box indicates which argument is to be used unmodified. Okay, so Henry is suggesting, let's look at an example. Sometimes the sequence of transforming, operating, transforming back should be applied to just one argument, with the other argument being passed unchanged into U. Okay, I understand. I think I understand this. don't seem to be logged into my server. 1 second. So it seems like these semi-duals work like this. So let's do the dual case first. So we say 2. Right, let's say we have a box 2 and a boxed 3, and we're going to add the 2 together. That's going to fail. But if we add them under unboxing, we're going to get 5 in a box. If we say atop this without the dot, right, we just get 5 because it unboxes both sides. But with under, it unboxes them and then reboxes them again. So a semi-dual then would be the case where we have this. So this is not. This is going to work because this works. You can unbox something that isn't boxed. But let's say you have a doubly boxed something. So we have 2. We have 2 over here, and then we have 3 over here. That's a domain error. That's annoying. I know exactly what this is doing. I just don't have a good example for it. So what's an example they used in the thing? My example is going to be unboxing, but unboxing already kind of has this behavior. So open Y but not X. All right. So okay. So let's look at their example. Open Y but not X and add X to each contents. Okay. So here's Y, and here's X. Okay, yeah. So this is what this is the same idea as what I was trying to show, but it actually demonstrates the problem. So now if we I think I lost something there, right? So you want to do this. You want to sum at rank infinity. So just add 10 to 100 to both of those things. You get a length error. But by putting the box over here, the empty box on the left-hand side, it says don't unbox that side. Trying to think through this on the fly, why you get the length error in particular, I'm not sure I understand why that happens. In any case, that's what a dual is. So I'm not sure I did a very good job of this, but you apply the unboxing operator to only one side. So anyway, the request is that to allow passing in an n, a noun, as opposed to just the empty box. So this is called the ace, right? This empty box, they call it ace. That Is this the same thing that's already done? I don't know. UVV. It doesn't look like it, right? Because it looks like the semiduals only have support A as the ace is the argument. So is he saying that is equivalent to NMV? It is just absolutely not clear to me what this means. U of V. Oh, well, let's read it. This is making the right argument is a verb. Then there is another verb. And then there is a noun. So this is a fork whose left argument is x, or whose left tongue is x, right? So it is a noun. The noun passed to this. So this, you're going to apply x, v, y. So that is the left tongue, and then x by itself. And then those go to this. So the first thing we're going to do is we have a hook. And a diatic hook is a weird thing. I almost never use diatic hooks. So I really don't know what they mean, but obviously Henry uses them. Obviously other people use them. I am very productive in J, but I have a lot to learn about the language. I use like a very small, it seems to me I use a very small subset of it. So anyway, I'm just going to say that there's this idea of semiduals, and it has something to do with using, to applying the un-Uing, if you got U and V. I'm sorry, actually the un-Ving. So you've got the V side is applied to, normally the V is applied to both operands, and then U is applied to the result, and then the inverse of V is applied, right? Which I guess this is what this is trying to say, but this is specifying how to use N, except it's not. So it was
it was confusing me because I'm going to open this ticket. I believe this is done. I believe this is implemented, but what I'm confused about is the case that maybe this was was intended for something to do something with n, but so one principle of J is this idea of rank, and the rank of a verb, you know, nouns have a rank. The rank of a noun is the number of dimensions that it has. So a two-dimensional array is a rank 2 array. A verb operates at a particular rank, and they're kind of like relative. So if a verb operates at rank infinity, it operates at whatever the highest level is. So if you pass it, like if you put a plus sign in between two arrays, and one of them is a rank 10 array and one is a rank 9 array, they work at the highest level of both of these things on both sides. Or you can have a rank for either argument. You can have the right-hand argument rank and the left-hand argument rank. You can never raise the rank of a verb. You can never take a verb that was designed to work for scalars, you know, for atoms, for like individual things, and then suddenly somehow make that smart enough to handle lists, right? It's like there's like a minimal amount of structure that it can have, that it requires, and so you can't. It makes no sense to reduce the rank of an array, the rank of a verb. However, you can. I'm sorry. It makes no sense to increase the rank of a verb, and because that would require more knowledge. It would require the verb to have more knowledge of the structure or whatever. It would require the verb to have knowledge of a bigger structure than it actually has. So instead, you make your verbs handle the largest rank noun that you can, the maximum generality, and then you can reduce it down to operate on a lower rank. So once you have a table, if you have an operation that works on lists, you can apply that to. If you have an operation that works at rank infinity, you can apply it to a table or a list or scalars all the way down, and reduce it. So what this is saying, this is that reduction step. So this is a version of under that applies at rank infinity, which is which I think we just saw here. The infinite rank version here. Yeah, so the form using the and dot is defined in terms of the infinite rank version. I think these are exactly the same. So in other words, the fact that hang on. So the n is actually telling it what rank to use. In this proposal. So my guess is either this predates the actual implementation of semiduals, or it is a reaction to semiduals and asking for an enhancement to the semiduals. So I'm going to, wow, this took a half an hour for one issue. This is crazy. I will not do this again. I'll not do this kind of detail again, but whatever. Sometimes I learned some stuff. Maybe, did I? I don't know if I could put it into words what I learned, but semi-duals. From JWiki. And this is gonna screw up. So we have to double escape the expressions because they have a backtick in them. That's what we learned yesterday. X to the y is x times under x to the y is x times, that's logarithm, right? Is it true that x to the y is x times log? I'm not a math person. I don't know if that's true or not. I believe that's what it's saying at the moment because it sounds plausible to me, but I don't know if it's true or not. All right. Henry Rich. Where's my button? Goes new issue, and I'm going to add a comment to this. Commentary at Henry H. Rich. Is this already done? We have semi-duals. I see we have semi-duals. I'm guessing I can't tell if that was because that was implemented because of this request, or whether this is a request to have to use n for the rank instead of just allowing a for n as a numeric, so use a numeric for the rank instead of just allowing it, just using ace for n as we have now. Okay. Well, that was complicated. It wasn't complicated. It was very mathy, and I'm not a math person. Although I found I've learned a whole lot more of like even simple basic math that I probably forgot from the old high school or whatever. Just from I learned a lot more about, or even relearned a lot more of that stuff just from using J. Shutdown callback is very important in my mind. It is certain packages such as database managers and HTTP servers. Yeah, you basically do something at shutdown. Just have a call. I don't know if it's very important. So the foreign 255 is called directly by JQT and JConsole when the admin shuts them down via exit or the checkbox. It would be very useful to execute a user-defined verb prior to shutting down. No names. Yeah, so having a shutdown callback makes a lot of sense to me. They didn't. This one isn't marked up, so let's. JQT. I don't know. Shutdown callback. And that was John Roby. Huh, suddenly the date stamps started changing. Yeah, date times here. So that must be the old wiki or something. All right, so I think that's pretty self-explanatory. Just have a way to call something when the thing happens. Let's edit that. We don't need the talk part. Okay. Shut down, callback. Where do we go? So J has this weird symbol. I think it's $, colon, which is meant to allow you to make recursive tacit functions or tacit definitions, and this is asking for the Henry A. Trich. This is asking for an explicit version of that. In my experience, the $, has the effect of causing a stack error and does nothing else. I've basically never gotten it to work. Except the only way I've ever gotten it to work is by going to self-reference and copying one of these things exactly. Otherwise, I just always get a stack error anytime I've tried to use it. So anyway, tail recursion. Okay, that's even better. I think that says something about my my abilities with J. Tail recursion. And maybe just that I haven't really looked at it all that hard. Okay. All right. Tailed recursion can be detected when an explicit definition is running. The result of the current sentence is guaranteed to be the result of the verb. Okay. The sentence issues a recursion to the same explicit definition. All tokens have been removed from the queue to the stack in the parser. That means that we're at the left side of the thing. So, in other words, either the leftmost item in a thing, if it starts with a noun at the end and goes all the way to the left, and the last thing that you're going to do once you've called all the other functions is to call this main function again, then yes, that's tail recursion. So no names are on the stack in the parsers. Yes, so that means you're all the way on the left. No. I'm not completely fluent with the way the parser works, but I think I have some idea. I worked through it in the past. It's just been a while. But so the queue is you're moving from right to left and then reading through all the tokens. But then you have to actually evaluate them, I believe. No, wait, no names are on the stack in the parser. Okay, so you've parsed the thing, you have the stack of what you're going to do, but no names are on the stack. Meaning that the names are not, you know, if the names are evaluated, their values would be on the stack. So the names are unevaluated. I'm not sure, but this is a note for Henry to himself, basically. So he understands it. The idea of tail recursion is very simple. This is if you don't know what it is, go look on Wikipedia. But it's not a J thing; it's a programming thing. But this is very specific to the J, the interpretation of the J parser. So anyway, that's that. I'll go ahead and put his
credit where credit is due. And that is Henry Rich. Update. I'll go ahead and put even the even this. All right, fast support for list I list where Y is in order. Does this not work? Oh, fast support. So this is, I know this works because I use this. I use this all the time. So I think he's talking about just an optimization for this. I actually tried to explain this the other day. So, you know, the idea is that you've got you know, you've got like a list of like say powers of 10 or something. So you got 0, 10. 100, 1000 or whatever, and you want to find like sorry, not I, but you have that, and then you use capital I, and then you have like say 50. What power of 10 is that? Except you pass the arguments in the other order. So 50 is 2 power of 10. But these bins can be any size. I'm just using powers of 10 as an example. So if you go all the way to 100, I think that's 2, and then 101 would be 3. It's not. It has nothing to do with powers. It has to do with the size of these bins. So if we say that this is 99, then 101 is still 3, but now 100 is also 3, right? And just because it's 1 over 99, one more than 99. Anyway, so if your list has to be sorted, and then this tells you where would you put this item in the index. And I'm guessing that there's some optimization for that. Maybe I don't know. My guess, like maybe this is just somewhat inefficient because I use this all the time. So the request would be if this is also a list. It's not clear to me what that means. What would it mean to be a list of a list? Would it I be 0? So I takes a list as its left. No. This is the monadic case. For the dyadic case, it works at rank infinity. So I don't know what the issue is. Maybe it just doesn't. I don't know. I use this all the time. I have a 2-dimensional list of you know. So in my thing here, we've got this thing called index, and that's my list of all the slides that have. So we've got the slides that have over here. If those slides contain commands. Then each line that has a command on it will be in this index, and so it's slide number and then line number. Sorry, and then if you want to look up, okay, well, you're on say page 1 or slide 1 and number 3 in line 3, where are you in this index? And you should be on number 4. So 0, 1, 2, 3, 4, which is right. So you're in between these two. So this works. I don't know if this is a request to make it faster. Maybe this is just slow code, and I don't know. It seems to work fine for me. My lists are very small, so I don't know what the meaning of this is. Like I don't know what the request for the changes. So whatever.
course, I have a table on the left, so I don't know what it means. I don't know what this means. I don't understand this one. But whatever. Let's edit this. I don't have to understand it. Maybe Henry understands it. Update comment. Ah, this is a controversial one. And I think either Henry or Marshall what's his name, Lockbaum? Sorry, I don't. The guy that makes BQN. They were talking about this on the Arraycast in one of their interviews. They talked about this. But this, I mean, I think I asked for this. I and many other people have asked for this, and then Roger Huey didn't like this because it doesn't have a clean inverse, but it kind of has a natural inverse. It doesn't have a unique inverse, but it has like a natural inverse, right? And the verb with an appropriate left argument is in left inverse to I, ignoring trailing zeros, and a right inverse to ignoring ordering. It counts for each number in, where n is the length of the left argument. How many elements on the right are equal to it? So let's look at the example. I'll look at it over here. Well, let's look at it in the preview, so make sure it's formatted right, and then we'll talk about it. 1, 2, 1, 2, and anyway, so this actually works in BQN, and maybe that's time to reconsider this. And we will use his Henry H. Rich. Okay. Just kind of preview this. Yeah, that looks reasonable. So you have this example here. Interesting. He's a K programmer, so or not K, APL. So he's not used to calling that Y. I would call that Y if it's the right argument. But sorry, I accused you of being a K programmer. In K, you always call the first argument X. All right. Well, anyway, they're suggesting this to be the inverse of IY. So hey, Martin. The optimization is considering the case where Y has multiple items. These happen to be in sorted order 2. Oh, that makes sense. Did I get it backwards in my demo, or just when I was talking about it? I was using a little tilde here, so. Yeah, that makes perfect sense. So I'm going to actually add your comment to the, or maybe you should add your comment here. Yeah, so this is JSORT. You should add your comment here. I don't need to quote you. if you have a GitHub account. Because yeah, this was, I'm sure it meant, you know, he knows what he's talking about. You know what he was talking about, but I had no idea what he was talking about, so that was confusing for me. All right. Okay. All right. let's see. In that form, the inverse would be a dyad, which would prevent its use in duals. Oh, anyway, so I was going to say, I 1, 2, 4, 4, 7, 8. For each number where n is length of the left argument, how many elements on the right are equal to it? The left argument, how many elements on the right are equal to it? For each number in I mean, I understand this. So this is just so on the, it counts. How many elements on the right are equal to it? Is that really an inverse? I mean, okay, so what does the monadic I dot do? It does this. So you, as a simple example, if you have, this will tell you the indices of the ones, right? So 3, 7. So how can you get 3 7s to put, or 3, 7? Oh, hang on. And then a 2 down here. So now what does it do with 8? 3, 7, 8, 8. Okay. Right. So now given 3, 7, 8, 8. Okay, I see now. So given 3, 7, 8, 8, let's see if I can reconstruct what he's doing without looking at his code. So given that, you might so sum the individual lines, right? No, hang on. 3, 7, 8, 8. I should just copy and paste this stuff and not think about it, but three, 7, 8, 8. So now if I take I and the length of that equals I and the length of that sorry, the baby's waking up. I need one second here. More than 1 second. Yeah, so we I kind of get what he's saying. You want to count the number of times. All right, so as you go 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, you really do want that. You want I times the length of 3, 7, 8, 8. Or not times length. You want to take the length, you want to count that. So that gives you 0, 1, 2, 3. But you also want to count them, right? So we have these two things now. And so we want to take that and we want to sum it on rank 1. So sum this way. So we'll have 1, 1, 2. But compose that with this 1, 1, 2. I, Y. Yeah, so Martin is saying, click, I don't want, he's saying that the documentation says this, that these are equivalent. IY is length of I. Which is a fork, so this is same as this, right? Right. So this is for those of us who are hook challenge, not a fork, it's a hook. Our hook challenge. This is Y. So I count length of Y. So Y. So like 1, 2, 3. We take the length, I length 1, 2, 3, which is what you get here. Right. So what's happening is you're making a number of how do I put that into words? You're taking for each slot. So if you have I of 0, this is index 0 is going to give you 2 zeros now, right? Now if I do another 2, we're going to get 2 1s. We're going to get 2 3s, or 2 2s, and 2 3s, and so on. 2 3s. So at least for me, the most common thing you would do is you would say like, banana equals n, right? And you get this thing back, and then you say I of that, and it gives you the indices of banana, where the letter is an n. So if you say 2, 4 of banana, you will get 2 n's back. So that's kind of the point of it, but it also is generalized. So if you have more than just a bitmap in here, you can have I, 0, 1, 0, 1, 0, 1, or 0, 2, and then you'll get 2 of the last one. So then the question is okay, now given this I355, I3 or sorry 1355. I don't know where I got I from. How do you map it back to this? Which is 0, 1, 2, 3, 4, 5 items long. So you know that like whatever the max value of this is. I had a whole rant yesterday the other day about how I get min and max missed, or greater than and less than messed up in J, because never mind. Because it evaluates right to left. But anyway, so so we know the max number is going to be is going to give us these numbers. What am I trying to say? The length of the result is going to be 5. So whatever the max number is going to be 5. And so we have these numbers. Whoops. Because this applies to that. So take this. All right, so and then I had this, right? And I was going to make something with these two objects. I had something else too. I had done something else previously as well. He's talking about the length. And I was talking about the max. That's interesting. Anyway, so the sum of rank 1 at equal 1, 1, 2. Okay. 1, 2, 3, 4. The sum at rank 1 Oh, but you can't just do that, right? You need like a table, right? So we have to take the max, and then we have to say equals, make the equals table with that thing. One, 3, 5, 5. No. We want. Okay, let's. This is actually kind of complicated. So let's take the answer that they've provided. I am realizing that like every time I see one of these issues, I'm realizing just how small of a fraction of the language I get by with. Because I do not, like this does not mean anything to me. To understand this, I would have to go look up. I mean, I see what it is. You know, we're doing an amend at rank 1 of X, okay, and then we're using a gerund to describe the behavior of the amend, and I have no idea what that does. I've probably used it, but I've probably looked. I've done. You know, I remember using gerunds with amend in the past, and I have no idea what this does. I guess I'm not the right person to be given this to be given these explanations. So I could try and struggle and for another hour and try and implement this, but I just want to get this done. So anyway, it would be nice to have an inverse for I dot. And the contention is that you don't know how many zeros come at the end, right? Because if you ask for, 1, 2, that's fine. But the issue is that you can put as many zeros as you want. So there's not just it's not a bijection. Like whatever the inverse is cannot possibly be a bijection because there's an infinite number of mappings onto there's an infinite number of these that so you can't always map to an infinite number of these map to the same to a single one of these, so you can't have a true inverse of this thing. And in fact, so if you were doing whatever the inverse is under using under, the length might change. So you might start with this and then do some operation. I don't know what operation you would do, but and then you would get back a different you would get back a different string or whatever. Even like identity under that, you would get back a different string. Yeah, you would think that a rule would be that this is the case, that no matter what you gave to this to this function, so this is sorry. Yeah, this is what I'm saying. So identity, the invert, I guess what I'm saying is this, right? So this is just the inverse of the identity should be which should be the identity, right? 1 1 whatever it should, that's true. But I guess the point I was going to make is that identity under identity should be the same. So identity under any operation should be the same. So if you double it, yeah. And so then if you put -1 here, you would expect this to be the same, and that cannot possibly happen. It can never happen. You get a domain error because it's not implemented, but it just plain cannot happen. So there is no universal inverse for -1 or for I dot. So how do you say this? You say B -1 tells you what the inverse is, I believe, and it gives you a domain error. Whereas say plus will tell you that it's or double gives you back half. Yes, baby. Come on. So anyway, the general request is to have some inverse for I, even though it is not possible to make such a thing, because there is kind of a natural answer to it. Like you would just the natural answer being this is probably the one you want. You just accept that you're going to lose the trailing zeros. And then this is a particular implementation of it. So I guess 2 particular implementations of it. Okay. But I could not tell you what they mean right now without significant study. All right. Expanded multiple assignment strawman. I think that indicates that it is not a. Oh, sorry. I didn't mean to do that. I meant to make a new issue. Why does making a new issue? That was weird. I have already submitted this 25 minutes ago, apparently. Okay, well, new issue, and I'll just clear that out, I guess, whatever. So expanded multiple assignment strawman. Strawman indicating that it is not a true proposal. It is, well, what does it even mean? Expanded multiple assignments. So you can already say this. No, you cannot say this. But you can always use a string on the left-hand side, and if this didn't have these brackets, then you could say A space, B space, C space, D space, and you could assign multiple items. So with this bracket, and you can also use like a backtick here to get to parse the right-hand side thing as a. You can provide like the gerund form, the atomic form, and parse it if you have a backtick inside the quotes here. And so you can create a verb or something that way from a gerund or something. Let multiple assignment handle more cases default value. So basically just add more features to multiple assignments, like this nested option. Destructuring assignment, basically, which I think is cool. I would give this a thumbs up. So let's format this. 1, 2, 3. One, two, three, and I think that is, yeah, I don't know why GitHub uses a variable width font for this. So BNF description backus nar form, nar. The guys that made Algol invented this syntax to describe their language in the big conference back in the 50s or something. So we need one of these. The name ends with question mark. The assignment is not performed if the name is already assigned. Interesting. If the name ends with dot or possibly preceded by dot or colon used for the assignment, character overrides the namespace used for the assignment. What? Oh, I see. So yeah, you could use global assignment or locale assignment versus local assignment, and public assignment, public and private. I like that name. I like that. Match an item but perform no assignment. Yeah, this is good. So destructure, but have a empty value. Yeah. I would almost suggest use underscore for that. That's what most languages I know use. And you would never assign to infinity, so I guess it'd be like writing to dev null or something. But whatever. It doesn't matter to me what language this is. Submit new issue. Okay. Did that come out good? Did that come out well? Okay, that looks mostly reasonable at a first pass. Support assignment in tacit expressions. That's funny. I was just talking to Henry about this yesterday. In fact, I linked him. I linked to this on the J discussion forum, and Henry responded saying that he is opposed to the idea of assignment in tacit functions, in tacit expressions. Although perhaps it was more my rendition of the idea. And yeah, so that's two of those dots are J token, and one of those dots Henry Rich. Oops. Sorry, I keep pinging you in these things, Henry, if you ever watch this. Anyway, he's probably changed his mind on this, but it's what he said, so, or maybe, yeah. All right, support pre-lookup of names in explicit definitions. Have a function that will scan an explicit definition and replace library names with a pointer to their definition. Could be invoked by a different left arg to colon, perhaps. And replace library names with a pointer to their definition. New issue. I think that just would be an optimization for explicit definitions. Although you have to be very careful because sometimes you'd want to make sure that you you don't want to lose the ability to have late binding, right? So you have to be able to mark like some of your pointers as dirty or something. So maybe you'd have to do like ref counting on the verbs on these definitions so in the library, and then okay, so you've loaded your library, you've got things calling that library, and so any names that were overrode in the future would have to kind of like, I don't know, you'd probably have like some kind of indirect binding or something. I don't know. Or it could work like, you know, f dot, where it kind of like bakes the function. And I misquoted that. That should be a comma is not part of the syntax. It's a left argument to colon. Colon is the tool, is the conjunction that allows you to create explicit definitions. Pre-parse parenthesized primitives. This is implemented. I believe this is implemented, and the idea is that scans an explicit definition. So within an explicit definition, looking for parentheses size sequence containing, or rightmost sequences containing only primitives or pre-looked up names. Again, I hope that they did something about late binding, or to preserve late binding, because you don't want a pre-looked up name to be changed, right? So I believe this is implemented, but I'm gonna just ask. I believe this seems to be implemented. But does it preserve late binding? Because that would be nice, because we want that. But how does it preserve late binding? But how does it preserve late binding for the pre-looked up names? Like if for primitives, it makes perfect sense. So if you have like a noun and a like if you have like, you know, I10 somewhere in your explicit definition, there's no need to evaluate that at runtime because I dot is never going to change, 10 is never going to change. So it's like a, you know, constant evaluation. And the result replaces the sequence in the explicit definition. So yeah, I mean, even if you do this in like a tacit definition, you know, so I10, you know, so you make a hook, you know, plus right argument. So that's going to give you Interesting. I could have sworn that did. Anyway, that's what this is talking about. I could have sworn that that always evaluated to I10 in the past. Like it would have always given you the first, these numbers inside like the definition, like they would have been baked into the definition for a tacit value. Okay, I guess I'm wrong. Maybe this. I'm curious what this does in J 903. This is. I'm not running the latest beta that has his fixes in here, or not fixes, but his implementation of this. So I wonder if that does it. But he's talking specifically about explicit definition. Maybe it's the case that there's like some no. Okay, so that did something, right? It did simplify it somewhat in the old days, and there's I can promise you there are some cases where you get like a noun here where you used to have a verb. There's some amount of simplification here, but maybe maybe counting is just so simple that it just doesn't do that. What do we do for shape 0? It could also be the case that so if you do 0 0. Oh, Martin's got an example. F. There we go. So if you do some arithmetic in there, it'll fix that for you. And is it also doing that for the for a fork? Yeah. Okay. So yeah. So sometimes it'll evaluate. Anyway, I guess this is enhancing this. The whole notion of preparse parenthesized primitives is that this is extended to the to explicit definitions. All right, fold. Fold is implemented. I skipped over the explicit definition. I'm going to skip over fold. Fold is implemented, so or the direct definition. So I'm going to skip over this. Support conditionals that stop evaluation early. Yeah. J has no short circuit evaluation. You can implement it like kind of with functions, but so if you want to say this right now, you have to use like if a is greater than or equal to 0, do if sentence that fails if is less than 0, do, and so you have to do like a nested if. So I would love this. I would happily vote for this if I had an option to vote. It does not matter what my opinion is of these things. Obviously, I'm just giving my commentary as I do this. What do I know? A++ would love to see this. +1, how about that? +1. All right, implement. This thing to amend inside boxing structure. Yeah, there's a there's an equivalent of this. The left curly brace and then followed by 2 colons lets you extract from a boxed structure, like a deeply nested structure. So having the other version would be wonderful. Being able to insert at that structure would be wonderful. I also very much like this notion. But I will not leave commentary on every single one. Submit new issue. Change definition of negative level. Negative level will be redefined to mean execute U within the box noun on every cell that is enclosed by exactly n boxes. Interesting. So level is something like rank, but it has to do with like nesting of boxes. So at level 0, you are talking about the individual contents of the innermost boxes. So like this would be at rank, these 3 things would each be at rank or at level 0. So I have no idea what negative level means right now. But I'm not going to stop and find out. Maybe in editing I will look this up. It is 9 o'clock. Do I want to take another day on this? Oh, data teleport. That's interesting. Talk there. That came up on the list this yesterday as well. I don't fully understand it yet. I didn't read the proposal here yet. I think there's also like a wiki page about it somewhere. And it's all about just like piping data through trains in different ways. And I haven't. Well, I guess we'll get to that soon. Cells whose boxing level is less than n are left unchanged. And so let's do these. Let's put a asterisk there. Henry seems to be the #1 suggester of features by my count. We saw from Igor yesterday. A simple way to overcome trains data flow restrictions would be a primitive to establish a data pipe teleport. Okay, so copy. New issue. Data teleport. I think pronouns, aka variables, satisfy the description. No, not exactly. Well, yeah, I mean, only if you can assign them inside the thing, inside the. Yeah, I think I'm gonna. I made a post yesterday that talked about some ideas that I'd like to explore in J, that I have explored in J. So let me put a link to his. Since I don't know if he has a GitHub account, I will just link to his wiki page. And then Raul said, I know Raul has a I can't imagine there's any other. Oh, I'm following him, so that I can't imagine there are any other J enthusiasts named Raul on GitHub. So already am. Since this is a comment, should I put it in a comment? Separate comment? Can I click on him now? Oh yeah, that's cool. Okay. All right, how far are we from the end? Improve format. Oh, that's the last one. Well, we'll save that for next week. No. Improve format. Improve format. Okay, what is format? The dyad numbers, right? So double quote dot. Oh, so he's got numbering here. I don't know if I'm going to try and do that. So double quote dot is called do when it's a monad, but it's called numbers when it's a dyad, and it tells you how to parse a string. It takes a string as the y argument, and it takes okay, so it takes some kind of numeric code on the left that tells you how to parse the string as a number. I've only ever used the number 0 in there, but I think there's other things you can do. Martin says, L:proposal, the real point of the proposal is the exact. The original current, the quote unquote exact. The original current behavior takes the level as an upper bound and applies to lesser depths as well, too. I agree that this is extremely irritating. So, okay. Now I'm curious to go back to look at that. So if you wanted the current behavior, could you just go back and put? Oh no, you wouldn't necessarily want. Infinite regress, right? You wouldn't. If you wanted your verb to apply to, 10,000 levels, then go all the way to the bottom. Then you. So how do you get the old behavior if you want that? I guess you use recursion, right? So as the example illustrates, cells whose boxing level is less than n are left unchanged. Interesting. I guess I've never used that. I haven't messed with boxes that much. I guess I have, but I haven't messed with nested boxes that much. I use boxes all the time. Occasionally nested boxes. But you would definitely work with these nested things when you do when you're working with gerunds and whatnot. When you have a atomic representation of a hook or something with conjunctions adverbs and all that stuff nested down inside of it. The dyad numbers, okay, so it understands infinity and not a number, but its close inversion via format is impossible. Is it possible to extend it to get blah, blah, blah? Sure. All things are possible. But that doesn't mean all things are good ideas. Not that I have a value judgment on this particular thing. I'm just saying all things. I guess many things are not possible. So I retract my statement. Copy link is format. And we will leave a link for posterity. Supports any precision. Wait, is it possible to extend it to get? And then two, are these two separate issues? I believe these are two separate issues, so I will one of two, and we will attribute that to Igor. I suppose I should look for him as well, now that I've done all this. If I find such a person that, not in this user, but in all of GitHub. Nope. One more time. Users, one user. Vladivostok. You got 5 repositories dealing with matrices and J. I believe I have found the right person, so let's if nothing else, I will ping this person now by attributing this to them. And then they can tell me, hey, you got the wrong person. And then I will put this here for posterity, just in case I did get it wrong. But I almost am certain that that is that same person. Copy link. Oh, I want to copy. Yeah, copy his. Igor Zhuravlov. All right. I think this is possibly the second most active requester. All right, and one more new issue. Two of two. So this is asking for more decimal places. Nower rhymes with hour, so it's Bacchus Nower form. Interesting, Bacchus Nower form. I've always said Naur in my head. Okay, so that's Nower. Thank you. All right. And again, we are, what was your name again? JIP? All right, the notorious JIP. All right, please feel free to come in and claim your tickets if you, I don't know how you can claim them. But I guess follow the ticket or whatever, I don't know. I guess you can subscribe to a ticket if you want to follow one of these things. So then anytime any discussion happens on that particular ticket, you can get information about it. So I should probably go through and do a second pass on the ones I've done yesterday, and probably even today, and just kind of double check that I didn't completely miss some links or something like that. But I think that I pretty much covered everything there is to say about our 32 or however number there are now that we've dropped some and broken some into pieces. But anyway, I'm done. So I think as far as this stream goes, I'll be back here tomorrow, but I don't know what I'm going to be working on. Probably, hopefully, just actually working on my own code again and kind of going through my bug list. And then for anybody watching this expecting a video on YouTube, they're coming. I'm editing and kind of rethinking how I make the videos. So the videos that go to YouTube and the live streams are going to be kind of decoupled. And the baby's waking up. Or not awake, but what you want? Yeah. All right. So I'm out. See you guys tomorrow. Thanks for the feedback, Martin. And yeah, talk to you guys later.